Welcome to Ask and Learn.
So we have this set of sets here with our relation being subset of, and they want us to answer a couple of questions. So to do this, it would help if we create a Haas diagram. So let's go ahead and do that first. So I'm going to start over here on the right-hand side and then work my way to the left. All right, so let's see. So is 2, 3, 4 a subset of any of these? So actually what I'm going to do, instead of writing the set, I'm just going to write the numbers there since all these are one digit. So I'm just going to do 2, 3, 4. Well, this is not a subset of any of the other ones, so we can go to the next one. All right, now what about 1, 3, 4? Well, this is not a subset of anything either, so we put these along the top of the Haas diagram. Now what about 3, 4? Well, 3, 4 is a subset of both of these. So we have 3, 4 here, so they would go below in the Haas diagram. Now for 2, 4, well, this is only a subset of 2, 3, 4, so we can put this over here. And then 1, 4 is only a subset of 1, 3, 4. All right, and now 1, 2, this doesn't look like it is a subset of any of these. So 1, 2, I'll put over here on its own. All right, now 4, so it would be a subset of all of these here. Let me draw it a little bit better. So we have 4, 4, and 4. And so these would also be a subset of our upper ones. But remember, the Haas diagram says we assume that it's transitive. So going from 4, if this is a subset, then since 3, 4 is a subset of both of these, then 4 has to be a subset of those also. All right. And then similarly for 2, this is going to be a subset of, this is going to be, I'll do this in red. So this is going to be a subset of this and 1, 2. Or better yet, let's just move this to the other side. The benefits of working on technology as opposed to paper, I guess. All right, but so we have 2 here, and then those would connect like that. All right, and now we have 1, which, so this is where we'll have to do that again. So 1, well, this is a subset of 1, 4, and it is a subset of 1, 2. Okay, so now we have our Haas diagram right here for this. So Haas. All right, so now let's see if we have any maximal elements. So remember, a maximal element in the Haas diagram is going to be something that has nothing above it. So, or in other words, there are no sets that contain it in this sense. Well, let's see. 2, 3, 4 doesn't have anything above it, so we can go ahead and write that. So I'll actually write these as the sets now. 1, 3, 4 doesn't have anything above it. And notice 1, 2 doesn't have anything above it. So those are going to be our 3 maximal elements for this. All right, now for our minimal elements, I'm going to go ahead and scoot this down a little bit. So for the minimal, these are going to be where they are contained in some set, but they are not contained, or they don't contain any other sets, or at least sets of S, we should say. All right, so let's see. Well, 2, 4, and 1 seem like good candidates. So 2, 4, and 1. And these are all good candidates since notice that 2 is contained in at least 1, 2, but 2 doesn't contain any sets. And then likewise, 4 is contained in 2, 4, but it doesn't contain anything. 1 is contained in 1, 4, but it's not contained in, or it doesn't contain anything else. So that's why those would be minimal elements. All right, now for greatest element, so they just want us to tell us if we have one or not. Well, we're not going to have one, and this is since, notice that, so a greatest element means that in the sense of a set with subset as our ordering, then that set has to contain every other set. But, so there isn't one since at least, so we just need to show one element doesn't have this property. So since 2, 3, 4 is not contained in 1, 3, 4 and 2 and 1, 3, 4, not contained in 2, 3, 4, but both are maximal. So that would be our rationale for that. And now for the least element is going to be a similar rationale as to what we did for the greatest element. So this will also not have a least element since, so notice here, if we had a least element, then all of these ones down here would have something down here. So like if we had the empty set, then the empty set would be the least element of all of these, since this is contained in every single one. So essentially a least element is going to be something where it is smaller than everything else in here. But in this case, 2, we can't really compare 2 to 4, and we can't compare 4 to 1. So not, and we can just say since 2 not in 4 and 4 not in 2. Let me go ahead and move this diagram. Then I can move all this down also. So since 2 is not a subset of 4 and 4 is not a subset of 2, but both minimal elements. Okay, so now we want to find upper bounds of 2 and 4. So what this is telling us to do is to find sets that contain both 2 and 4. So if we want to look at our chart over here, we just need to follow to see what kind of overlap they have. Well, 2 and 4 both have 2, 4 above it. So we'd have 2, 4 as an upper bound. And then we can just follow this path to the next one, which would be 2, 3, 4. Okay. Now for the least upper bound of that 2, 4 there, well, we'll look at our upper bounds and then we ask ourselves, is one of these contained in all of the other? And it is the case that we will have one. So it's going to be 2, 4, 2, 4, since 2, 4 is a subset of 2, 3, 4. So that's going to be our least upper bound for this. Now, for the next one, for the lower bounds of 1, 3, 4, and 2, 3, 4. So instead of starting above or starting below and then working our way up, we're going to start above and work our way down. So we start here at 2, 3, 4, and 1, 3, 4. And then we look to see, well, what will these have in common? Well, it has 3 and 4 in common. And then, so this is going to be one of our lower bounds. Let me just write this down. So it'll be 3, 4. And now 3, 4 only goes to 4. So those are going to be our lower bounds for that set there. And now our greatest lower bound, so just like the least upper bound, so the greatest lower bound, we want this to contain all of our lower bounds. And well, that's going to be 3, 4, since 3, 4 contains 4. So you could do this without the Haas diagram, but I feel like using this helps visualize it a lot better and makes it a little bit easier to work with, as opposed to just kind of trying to do it algebraically purely. So the Haas diagram is really useful for these kinds